Today is the day when we are going to work on the last of our existing models, the neural network model, the code for training it, and let's just accomplish what we already got so far in our project. We got the getData method file which helps us to get the data for the stocks, and I believe we can update it here because today is already October. Just let's update it to get the latest date available up to September. We got our main Streamlit application, which is helping us to have our web display in an interactive browser screen using Python and Streamlit. We got our linear regression model code, which will help us to give a prediction for the stocks in linear regression. And we got our random forest. We also have the list of stocks that we are going to do, and typical for Python project, the requirements txt file, which is empty, but at the end we will do one magic command which will help us to outline all our libraries that we used in any of the files and which ones that we got installed into requirements.txt. So it's time for neural network file, and surprise surprise, it will be pretty similar to the random forest, except for, well, 10 lines maybe. So instead of going again line by line by writing the code, let's just copy it, Control A, copy and paste, and let's go correct the differences. First of all, we are not going to import anything from sklearn ensemble, but instead of it we are going to import from TensorFlow Keras models, import sequential, and min-max scalar can remain. One more thing, from TensorFlow Keras layers, we are going to import dense. Don't get scared with highlighted in red lines. As we will see, those are not blockers for our work. So what we imported instead of previous, the sequential and dense, are part of neural network library, where sequential builds the model layer by layer, and dense is a fully connected layer, so it's connect the previously built layers. This whole part remains the same. Let's scroll down to the part where we were defining the random forest model here. RF model equals to, etc. So instead of this, we're going to build and train the neural network model. Let's remove these lines. So model equals sequential model, add dense 100, activation will be equal to RELU, input shape equals to xtrain shape 1 Just bear with me for a minute, we will go line by line over the code. Model, add dense 1, model, compile, optimizer equals to Adam was equals to MSP model fit xtrain ytrain epochs equals to 10, batch size equals to 32, variables equals to 0. Now, what we did here, this line here help us to define a sequential neural network model. Layers will be added one after another. Dense equal 100, activation equals ReLU. The first layer is fully connected layer with 100 neurons and uses the ReLU activation function. This layer receives an input which is past 100 days of the stock prices, hence comes 100. Dense equal 1, the output layer with the 1 neuron which represents the next day's stock price. Compile is using the Adam optimizer and mean square error function loss. Then the fit is training the model on the training data for 10 epochs with a batch size of 32. This means that the model will see entire data set 10 times. One epoch represents one time when the entire dataset has been reviewed, and will process 32 of examples at a time. Lastly, we are going for the same saving of result files. So model, save, fstring, model directory, and then symbol, and you remember here the RF was RFPKL, and here it will go by NN Keras. And print model for symbol, saved as symbol underscore NN Keras. One more time about the script. The same basic flow that it was for the random forest, and also we didn't need joblib library to be imported for this particular file. We start with the input. The script loads the stock from CSV files, one of each stock symbol, pre-processing the data by normalizing the prices, creating input-output pairs for training. Neural network is trained here in a part that we just modified. It's trained on the historical stock data using the previous 100 days to predict the price for the next day. After training, model saves the file. What you need more to know about neural network? It's another machine learning model inspired by the way that human brain works, actually. It's particularly useful for tasks that involve complex pattern and non-linear relationship. It's used widely in different areas such as image recognition, language translation. Some usage of it is in financial forecasting. It consists of the interconnected nodes or neurons, like different dots that are connected between each other, pretty much like graphs, or it represents, it works in a way that human brain works, so basically we can say that it represents like human brain cells. Each node receives inputs, performs computation, passes the outputs to the next layer. This network can model complex relationship between input and output data by learning the weights that optimize the model's performance during training. What is fully connected or dense layer? Each neuron is connected to every neuron in previous and next layer. So it's connection many to many, where every neuron is connected to the other one. Let's try to get an image. Neural network connections layers. I believe this will represent more clear than I will explain for 10 or 15 minutes. So basic introduction is this: input layer, all cells here connected to all in here, all here connected to all in here. The output is connected to all in the previous, and there is no next layer, so nothing to connect in here. This architecture allows the network to learn highly detailed and abstract patterns from the data. The activation functions, or ReLUs, this introduced non-linearity into the model, allowing it to learn complex patterns. The ReLU, or rectified linear unit, is one of the most commonly used activation functions due to simplicity and effectiveness. In the context of stock price prediction, why those are used? They are beneficial in this case because they can capture non-linear relationship in stock prices that simpler models can miss. Also, they can process large amounts of historical data to identify hidden patterns that may influence future stock prices. So in short terms, neural network is having a bit more complicated structure, the model itself, which helps to identify more hidden patterns that can be identified with the usage of simple linear regression or something similar to linear regression. And the benefit of it is that it can operate the large amount of data and identify more patterns than the regular linear or random forest model. So this was it. Our all scripts are ready, and tomorrow we are going to spend some time with the running the get data file. I can even get it running now, but before that, let's push our code to the Git, so Git repository will have all the updated information. Let's start with Git status. I didn't do much branching for this because it's really like working on separate files, not many modification of existing files. So I have branch master, which is up to date with origin master. Now we are adding all the modifications we made today. Git add and dot all files, git commit -m. We are providing a useful message which will help us to check what this commit was about. Added neural network train file code. We can see here that in all the changes that we did are applied. Now we can push the code to origin master. Git push origin master. And our code is updated on a Git, so who wants to download the latest existing version of it, they can go to the GitHub on the repository, which I will share at the description of this video, and download the latest existing one. And last, let's have get data part of our project running, so it will grab a data from Yahoo Finance, will download this data for stocks, and it will be saved in data folder. After which tomorrow we are going to execute one or two of this model because these tasks are taking a long time. Let's run the code. Let's see what we got. So this folder here is now getting the CSV files downloaded for stocks, which are included in this S&P 500 stock CSV file column stocks. Once again, let's open this. No, not stock symbols, sorry, my bad. Column symbol, the stock names are included in here, and our code is grabbing the name of each symbol from here, the first column, and provides that as input to our main method here, which is taking it and downloading the file for all of them. Okay, this concludes our session for today because there are 500 files and it will take a while for all of these files to be downloaded, but I think we came pretty close. It's on alphabetical order, and T, U, V, W, X, Y, Z. Let's open our data folder, and we can see a bunch of files in here, again in alphabetical order. And you remember our codes: neural network code, random forest code, and linear regression code. All of them have parts where the stock symbols will be acquired, and those will be processed with the prices in the date column. Let's actually open one of those. We can see the date here, 2021-014. We can see that the code is skipping some days, which explains that those will be weekend days, so no trades. And it will take close column values as stock closure prices. So tomorrow we are going to run all of this training for different models and see the results being populated in the models file in appropriate folder with the name and extension mentioned here, like linear regression PKL, random forest PKL, and just we did today, neural network Keras. Hope you enjoyed this session and see you tomorrow. Stay tuned for the updates. Thanks for your time and goodbye.